variation of g at different points on Earth. We did measure the acceleration due to gravity g from the equation g into m by r square. It means that the acceleration due to gravity is inversely proportional to r square. Means if r is reduced, g increases, and r increases, g reduces. Now we understand on the Earth's surface, if you see, at poles, r is minimum, r reduces, and at equator, r increases. So at poles when r decreases, what happens to g? G increases. At equator when the r increases, what happens to g? G decreases. So we understand that at poles, the acceleration due to gravity is higher, whereas at equator, the acceleration due to gravity is minimum. In fact, we can say that at poles, it is maximum, and at equator, it is minimum. So, they did some experiments and measured the acceleration due to gravity at different heights from the surface of the Earth. So, if we see that experimental results, g at 200 kilometers is 9.23 meter per second square, and at 10,000 kilometers, it is 1.49 meter per second square, and at 30,000 kilometer, it is 0.3 meter per second square. What it states, higher the distance from the surface of the Earth upwards, then lower the acceleration due to gravity. So it means that when it is closer to the Earth, acceleration due to gravity is higher. And also make a note that acceleration due to gravity formula is not applicable inside the g. That is, formula of g into m by r square is not applicable inside the Earth, and it is 0 at the center of the Earth. So this is something which we need to make a note, and it's maximum on the surface of the Earth. G is maximum on the surface of the Earth. That's the reason even at 200 kilometers is 9.23 meter per second square, whereas on the surface of the Earth it is maximum, which is 9.8 meter per second square, which is 9.8 meter per second square. So as we go down, as we go inside the Earth, or as we go higher up the sky, the acceleration due to gravity decreases. So that is what we understand. Acceleration due to gravity varies, and it decreases as we go inside the Earth, as we go above the Earth into the sky. So we understand from all this discussion that acceleration due to gravity does not depend on the mass, and it varies on where the experiment is conducted, on the surface of the Earth, or farther from the surface of the Earth, or inside the surface of the Earth. So it varies. Now let's see an example in order to understand this variation. A problem 1. The values of g at 6 distances a, b, c, d, e and f from the surface of the Earth are found to be 3.08 meter per second square, 9.23, 0.57, 0.3, 1.49 respectively. Now, arrange these values of g according to the increasing distances from the surface of the Earth. Now we understand from the variation of g, different points on the earth. Nearest to earth, first one, and farthest from earth is the last. So it means that nearest to the earth has high acceleration, high g, and farthest from earth has lowest g. So from this understanding, we can arrange .34. So it goes from highest to the lowest. Let's see the part B of the problem. If the value of distance be 10,000 km from the surface of the earth, state whether the distance is deep inside or high up the sky and give reason. Let's say it is 10,000 kilometers from the surface of the earth. If it has to be deep inside, then it has to be within the radius of the earth. Now we know that the radius of the earth is 6,400 kilometer, and whereas the point in question is 10,000 kilometers. And we also know that at center of the earth, the acceleration due to gravity is 0. G is 0. Hence, it has to be above the earth. So the answer to this is, it is high up the sky. Because the value of distance of F, the point F, be 10,000 kilometers from the surface of the earth, whether it is deep inside or high up the sky, is what we need to conclude. Now F does have an acceleration as per the question, which is 1.49 meter per second. Because at F, G is given as 1.49 meter per second square. So there is an acceleration. And 10,000 kilometers is much greater than the radius of the earth. And if it is deep inside, at the center of the earth, G is 0. So with all this data in, we conclude that the F is high up the sky. The point F is high up the sky.